Imagine this for a moment. You wake up in the heart of Beijing, the city just coming alive as the sun rises. You enjoy a leisurely breakfast, gazing out at the sprawling skyline, and then, with barely any rush, you grab your suitcase and head to the airport. But today, you're not boarding an ordinary plane. Instead, you step onto a sleek, futuristic jet, something straight out of science fiction. Just a couple of hours later, you're already descending over the iconic skyline of New York City, ready to have lunch in Manhattan. The journey that once took more than half a day is now just a brief interlude between meals. This isn't just a dream, it's the promise of hypersonic travel, a revolution that could change the way we think about distance and time. We're talking about connecting continents in ways that were once considered impossible, shrinking the world and bringing people closer together than ever before. For decades, commercial air travel has been stuck at subsonic speeds, with only incremental improvements in speed and efficiency. The Concorde was a brief glimpse of what was possible, but for most of us, the dream of supersonic or hypersonic flight has remained out of reach. Now, a dedicated team of scientists and engineers in China is working tirelessly to change that. Their ambitious project aims to make a 2-hour Beijing to New York trip not just a fantasy, but a reality within our lifetimes. The project is called Yunxing, or Cloud Star, a name that captures the spirit of soaring above the clouds at unimaginable speeds. The goal? To build a hypersonic jet capable of reaching speeds of Mach 5 or even faster, pushing the boundaries of what's possible in aviation. At those speeds, the world as we know it becomes dramatically smaller. Cities that once felt oceans apart are suddenly just a short flight away. Imagine attending business meetings on different continents in the same day, shaking hands with partners in New York before flying back to Beijing for dinner, or visiting family across the ocean for a weekend, making international travel as easy as a domestic trip. Of course, achieving this vision is a massive engineering challenge. It will require breakthroughs in materials, propulsion, and safety, pushing technology to its limits and beyond. But if successful, it could mean the end of the tyranny of distance, breaking the chains that have kept us apart for so long. Think about the cultural exchange, the new friendships, and the business opportunities that could flourish in a world where travel is no longer a barrier. There are still many hurdles to overcome, technical, regulatory, and environmental, but the pursuit itself is driving innovation at an unprecedented pace. For now, let's just marvel at the sheer coolness of the idea. The thought that one day soon, a 2-hour flight from Beijing to New York could be as routine as a cross-country trip. Picture it, a digital map showing a direct, 2-hour flight line connecting two of the world's greatest cities. The future of travel is coming fast, and it's more exciting than ever. What is hypersonic speed? Let's break it down and take a quick journey through the history of fast flight. The story of speed in the skies is one of constant innovation, daring pilots, and the relentless pursuit of going faster than ever before. Most of us are familiar with subsonic speed. That's anything slower than the speed of sound. It's the realm of commercial passenger jets, the planes we board for vacations or business trips, cruising smoothly at around 500 to 600 miles per hour. These aircraft are designed for comfort and efficiency, not for breaking records. Supersonic speed, on the other hand, is when an aircraft travels faster than Mach 1, the speed of sound, which is about 767 miles per hour at sea level. When a jet goes supersonic, it creates a dramatic sonic boom, a thunderous clap that signals it's broken through a fundamental barrier of physics. In 1947, test pilot Chuck Yeager made history by shattering the sound barrier in the Bell X-1, a rocket-powered plane shaped like a bullet. This achievement opened the door to a new era of aviation and inspired generations of engineers and pilots. The legendary Concorde took supersonic travel to the public, flying at Mach 2, twice the speed of sound. It could cross the Atlantic in under 3.5 hours, making it possible to have breakfast in London and lunch in New York. The Concorde was a marvel of engineering and a symbol of luxury and speed. Sadly, the Concorde was retired in 2003, and since then, commercial air travel has returned to subsonic speeds. The dream of supersonic passenger flight faded, leaving us to wonder what might come next. But there's another frontier, hypersonic speed. This means flying above Mach 5, over 1 mile per second or more than 3,800 miles per hour. At these speeds, the rules of flight change dramatically. When an object moves this fast, the air around it heats up so much that it turns into a superheated plasma, glowing and crackling with energy. The challenges of hypersonic flight are immense, from withstanding extreme temperatures to managing intense shock waves. In the 1960s, the North American X-15 rocket plane pushed the limits, reaching speeds of Mach 6.7. Pilots riding the X-15 experienced forces and dangers unlike anything before, paving the way for future hypersonic research. Hypersonic flight is often compared to riding a meteor, blazing through the atmosphere at unimaginable speeds surrounded by fire and plasma. The engineering challenges are staggering. Engines must operate in extreme conditions, and materials must survive temperatures hotter than molten lava. Every component, from the nose cone to the smallest bolt, must be designed to withstand the punishing environment of hypersonic travel. For over 50 years, hypersonic flight has been the domain of military projects and secret experiments, shrouded in mystery and national security. But now, a new chapter is beginning. China's scientists and engineers believe they can unlock hypersonic travel for everyone, not just the military or astronauts. The Yunxing project is China's bold vision to make hypersonic passenger travel a reality. Their goal is to shrink the world, making it possible to fly between continents in just a couple of hours. If successful, it will be a giant leap forward, a bold step into a new era of aviation, where the impossible becomes possible. The future of travel is on the horizon, and it's coming at hypersonic speed. Get ready for a revolution in the skies. Let's talk about the Yunxing, or Cloud Star. Unveiled by scientists from the Beijing Institute of Technology, it's a detailed proposal for a hypersonic jet. The Yunxing is designed to cruise at Mach 5, about 3,836 miles per hour. Its unique biplane-like design generates more lift, allowing it to carry more weight. This configuration solves the problem of generating enough lift in the thin upper atmosphere. The project is state-backed, with top minds behind it. The goal is a practical transportation system, not just a speed record. It's a bold, ambitious goal with fascinating engineering. The Yunxing could redefine global travel. How do you get a plane to Mach 5? That's over 6,000 kilometers per hour, faster than a speeding bullet, and far beyond what most commercial jets can even dream of reaching. Achieving these speeds isn't just about going faster, it's about overcoming the fundamental limits of physics and engineering. Not with regular jet engines. Traditional engines simply can't handle the extreme temperatures and airflow at hypersonic speeds. They're designed for subsonic and low supersonic flight, not the blistering pace of Mach 5. The solution is a hybrid approach with a combined cycle engine. This advanced system combines the best of multiple propulsion technologies, allowing the aircraft to adapt as it accelerates through different speed regimes. It starts with conventional turbofan engines for takeoff and subsonic speeds. These engines provide the thrust and efficiency needed to get off the ground and up to speed, just like the jets you see at your local airport. Once the aircraft reaches around Mach 2, the airflow inside the engine is redirected, and a scramjet takes over. This transition is a marvel of engineering, requiring precise timing and control. A scramjet works at hypersonic speeds, essentially keeping a fire lit in a hurricane. It uses the incredible speed of the incoming air to compress and ignite fuel, creating massive thrust without any moving parts. The Yunxing's engine system transitions seamlessly between these modes, enabling efficient operation from the runway all the way to hypersonic cruise. This flexibility is what makes such extreme speeds possible. But propulsion isn't the only challenge. The unique biplane wing design is key to the Yunxing's success. Unlike traditional wings, this configuration is specifically engineered for hypersonic flight. Here's how it works. The lower wing generates a powerful shockwave as the aircraft slices through the air, and the upper wing is designed to ride that shockwave, reducing drag and increasing efficiency. This shockwave compression lift effect dramatically increases overall lift, allowing the aircraft to stay stable and efficient even at extreme speeds. In essence, it turns what would normally be a problem, shockwaves and turbulence, into a solution that actually helps the plane fly better. The Yunxing's design uses extreme physics to its advantage, pushing the boundaries of what's possible in aviation. It's a brilliant way to achieve hypersonic flight, combining advanced propulsion, innovative aerodynamics, and cutting-edge materials. The combined cycle propulsion is crucial for efficient point-to-point travel across continents or even oceans, shrinking the world in ways we've only imagined. The Yunxing is a marvel of engineering, representing years of research, testing, and bold thinking by some of the brightest minds in aerospace. It's a step toward the future of aviation, a future where hypersonic travel could become a reality for all of us. The Yongxing project builds on years of research. A key stepping stone was the I-plane unveiled in 2018. It shared a biplane configuration achieving a high lift-to-drag ratio. The I-plane was a proof of concept showing the viability of the biplane design. The Yongxing refines these ideas into a complete system. China's aerospace community is building on successes and advancing capabilities. The journey from the I-plane to the Yongxing shows a maturing design philosophy. It's a focused strategy, not random ideas. The progression is a hallmark of great engineering. The Yongxing is a bold step forward. It's a testament to China's ambition in hypersonic technology. Why aren't we flying hypersonic yet? It's monumentally difficult. The cost of building and testing new aircraft is enormous. Materials for hypersonic temperatures are exotic and expensive. Safety is a major concern. Small malfunctions can be catastrophic. The environmental impact, like noise and emissions, is significant. Technical hurdles like combined cycle engines are complex. Material science is still evolving to handle extreme conditions. Guidance and control systems need to be foolproof. Solving these problems is a massive undertaking. The challenge is creating a reliable, commercially viable aircraft. It's a long road filled with potential dead ends. But overcoming these challenges adds to our collective knowledge. The journey is as important as the destination. Hypersonic travel could change global dynamics. It's a challenge worth pursuing. China isn't alone in the race for speed. The US has Boom Supersonic working on the Overture jet. NASA is tackling the sonic boom with the X-59 Quest. Other players focus on military applications. The Yongxing project stands out as a comprehensive effort. It's a state-driven push for a hypersonic passenger system. While others aim for supersonic, China targets Mach 5. This global competition drives innovation. It's a new kind of space race, shrinking our planet. The Yongxing project is part of China's push to lead in hypersonic tech. The government has invested heavily in this field. It's about mastering a capability that could reshape global dynamics. China has advanced hypersonic wind tunnels like the JF-22. These facilities speed up development and gather crucial data. Military tests provide knowledge for civilian projects like Yongxing. This state-directed investment is China's advantage. They can invest in high-risk technologies over decades. The Yongxing symbolizes China's ambition to lead. It's a declaration of intent in the hypersonic race. The project is a testament to strategic planning. It's a bold step toward the future. Is hypersonic travel real? Not soon, but not just a dream. The challenges are enormous, requiring years of work and billions of dollars. The road to a certified passenger aircraft is long, but projects like Yongxing push boundaries and inspire innovation. Every challenge overcome adds to our knowledge. The technology will improve conventional aircraft. The journey is as important as the destination. In the short term, developers gain strategic advantages. If hypersonic jets enter service, costs will eventually come down. Air travel was once a luxury. Hypersonic could follow. It could change global business and personal relationships. The Yongxing project is ambitious and exciting. It forces us to ask big questions about the future of travel. Whether it flies or not, the quest represents human ambition. It's a myth worth pursuing.